Okay, question number 1. Logarithm 7 times 2 by base 9. So here we're going to use properties of logarithm. Based on properties of logarithm, if we have product multiplication, then logarithm, let me get a little bit bigger. Logarithm a times b by base c is equal logarithm a by base c plus logarithm b by base c. Okay, so which means multiplication between them will be converted into addition. All right, so which means here we have it's going to be logarithm 7 by base 9 plus logarithm 2 by base 9. Okay, next question. Question number 2. Logarithm 13x by base 13. It's going to be equal logarithm 13 by base 13 plus logarithm x by base 13. Now, what means logarithm 13 by base 13? That means it's going to be equal, let's see, logarithm 13 by base 13. How much it's going to be? Which means 13, we're raising to what power to get 13? Of course, it's going to be 1. Therefore, it's going to be, we write down, this is going to be equal 1, right? Plus logarithm x by base 13. Shortly saying, if you have end result a and base a, so logarithm is going to be 1. Degree is going to be 1, okay? As long as it's the same number. Question number 3. We have logarithm by base 3 over y. Okay, so let's add the property for division. If multiplication is converted into addition, then division will be converted into subtraction. That's right. A over b by base c is equal logarithm a by base c minus logarithm b by base c. And this is going to be equal logarithm 3 by base 3 minus logarithm y by base 3. Now, logarithm 3 by base 3, it's going to be equal how much? This logarithm 3 by base 3. It's going to be equal 1. Yes? Okay, so it's going to be 1. Oops. Minus log y over 3. Why is it y? 1, because this 3 we raise to power 1 to get this 3, right? Okay. Next, question number 4. Logarithm y over 10. So, which means base is 10, right? Because we don't have here anything written. That's why we take it as a 10. Okay? So that is equal logarithm y minus logarithm 10. And logarithm of 10, look, logarithm 10, which means base is also 10, because when there is no base, it's 10. How much it's going to be? It's going to be 1, right? 10 to power 1 is equal 10. So we're going to get logarithm y minus 1. Question number 5. Logarithm 256 over y is equal logarithm 256 minus logarithm y, right? So if we have base 4, let me add base 4. So it's going to be base 4 here, base 4 here. Now, if we take logarithm 256 by base 4, so is there any degree 4 we raise to what degree to get 256? Or if you check on calculator, you're going to take radical degree 4 from 256. And that is going to be 4, which means 4 we have to raise here to power 4, and that will be 256. How did I came up with this one? We're going backwards. 4 to power 4 is equal to 256, or I can write down opposite operation. Radical of degree 4, this 4, here it's going to be equal 4. Okay, question number 6. Let me clean this mess here. Okay, question number 6 is equal natural log e to power 7 over 4. That is equal natural log e to power 7 minus natural log 4. Remember, natural log, let's say e to power 7 has the base e. So to get e to power 7, how much degree I have to raise to get e to power 7? Of course, it's going to be 7, right? So therefore, this is going to be equal 7 minus natural log 4. Question number 7. Log x cubed by base a. Okay, now I'm going to write that, add here the property of power, where power says if we have log a to power p is equal, this p comes in front always, power always come in front, which is going to be equal p times, why is so thick? Okay, we use this one, is equal p times log a, always come in front, the power. So which means in this case it's going to be this 3 come in front. Okay, so it's going to be equal 3 times log x by base a. Next, question number 8. Log c to power negative 5, when their base is 10. So we're going to get negative 5 come in front, will be negative 5 log and c. Okay, let me move these properties down, making mobile, so you can use. Okay, all right. Question number 9. So log z cubed y by base b. Sometimes they put parentheses, but if you have more than one terms, if you put parentheses, then this way you won't be confused, because if you put like that, let's say log z cubed y by base b, that can be interpreted as log z cubed by base b and times y, because there is no parenthesis in there. But if you include parentheses, so that means y is also under the head of logarithm. Okay? All right. So this is equal logarithm z cubed by base b plus logarithm y by base b. So we have here cube power, which means we are going to get 3 times, right, coming in front, 3 times log z by base b. So this 3 is coming in front here. Okay. And plus log y by base b. Question number 10. This is not difficult topic at all. Logarithm by base 2. We have square root of f over 4. So what do we have? Since we have division, look here. Let me do this way. Formula 2. This is formula 1. This is 2. And this is 3. So we're going to use formula 2. Division converted into subtraction. So it's going to be log square root f by base 2 minus log 4 by base 2. Okay, square root f is logarithm f to power 1 over 2 by base 2. Let me explain. Whoever doesn't remember this, square root a is equal. So here is degree 1 when it's only a. Here we have degree 2 when it's square root, right? So that is equal in the format of exponential at a rational exponent. It's going to be a 1 over 2. If I have, let's say, degree 4 and I have a to power 3, that is equal a to power 3 over 4, which means this exponent always comes to numerator, see? And this 2 comes here, denominator. Same thing, this 4, it comes here. Therefore, here we have 1, here is 2. We get 1 over 2, all right? Okay, and minus logarithm 4 by base 2. Now this 1/2 that we have, degree 1/2, what's going to happen with this power? Here's formula 3, right? We are using formula 3. This power is coming in front, which is going to be equal This 1/2, it will come in front, so it's going to be 1/2 natural log f by base 2 and minus, not natural, logarithm 4 by base 2. Okay. Now, logarithm 4 by base 2, how much it will be? How much is it? Logarithm 4 by base 2. Otherwise saying, 2 I have to raise to what power? Raise to what power to get 4? It's going to be 2, right? Okay. So we need to raise to power 2. So this is going to be equal 1/2 log f by base 2 minus 2. Okay, question number 11. Logarithm by base b for x squared y over z squared. So we need to expand this logarithmic expression as much as possible. So we are going to use all properties of logarithm that we have. Let me move it down, these properties that we are using so far. I'm moving here for now. So what do we get? In numerator, we are going to get, first take care of this division, which you're going to convert into subtraction, right? Logarithm by base b, x squared y minus logarithm by base b, z squared. Yes? This is going to be equal. Now, do we have here multiplication between them? Yes. So I'm going to open it. So this is going to be equal logarithm x squared by base b plus logarithm y by base b and minus, see we have here 2 exponent z squared, right? So can the z squared come in front? Absolutely. So it's going to be minus twice logarithm z by base 2. Next, here also we have 2, so exponent will come in front, and we will have 2 logarithm x by base b plus logarithm y by base b minus 2 logarithm z by base 2. Next. Question number 12. It's going to be logarithm radical degree 6, and underneath we have a over b. So, and base is 10, right? So can I rewrite logarithm radical degree 6a over radical degree 6b? Yes, I can. From here, can I rewrite? It's going to be logarithm a to power 1 over 6, right? Because this means 1 here. And let me put a little bit higher, so 1 over 6, we will understand that's exponent over b to power also 1 over 6, right? Okay, so from here, do I have division? I can subtract, right? Logarithm a to power 1/6 minus logarithm b to power 1/6. Okay, this 1/6 come in front, 1/6 come in front. And this is going to be 1 over 6 logarithm a minus 1 over 6 logarithm b. All right? Question number 13. So what do we have here? Log. We're going to use long expression here. It's here going to be 100x cubed in radical degree 3 minus x over 3 times x plus 7 squared. Okay? So, let's do it. So first of all, we are taking care of this division, right? Of this fraction, fractional line, which means it is gonna be subtraction, right? Since we have division. So that is gonna be logarithm and base is 10. So it's gonna be 100 x cubed, cubic radical 3 minus x, and this is going to be minus logarithm 3 times x plus 7 squared. Yes? Okay. Next, question number 14. Oh, wait a minute, I'm sorry. There is much more simplification, I didn't pay attention. All right. So next is going to be, now I'm opening here inside. So what do we have? We have 100 multiplied by x cubed multiplied by this cubic radical. So which means all of them is going to be converted into addition, right? So it's going to be logarithm 100 plus logarithm x cubed plus, so this cubic radical 3 minus x, I'm going to represent 3 minus x to power 1 over 3, because this means degree 1, right? When we have 3 minus x or 5x plus 6, so when addition subtraction, you're going to combine them and treat as a one term for these radicals, okay? So, and it's going to be 1/3, which is going to be logarithm 3 minus x to power 1/3, and then minus, let me put this into square brackets, because I have minus. When I open parentheses, it's going to flip the sign. It's going to be, so this is also, we have multiplication. So that is going to be logarithm 3 plus logarithm x plus 7 squared. Okay, let's finish it. Logarithm 100 by base 10. Look, 100 by base 10. What does that mean? 10 we have to raise to what power to get 100? 2, right? So it's going to be 2 plus this power 3 will come in front. Logarithm 3. Next, this 1/3 will come in front. Logarithm 3 minus x. This 3 minus x I cannot separate. You can never separate this 3 minus x because you don't have such property. Minus, it's going to be, so taking parentheses, because we haven't opened it yet. So we get logarithm 3, and then this 2, exponent 2 will come in front, 2 logarithm x plus 7. Now we can open parentheses and change the sign. This is going to be 2 plus 3 logarithm x plus 1/3 of logarithm 3 minus x, and then minus logarithm 3, and then minus twice logarithm x plus 7. And we are done here. Okay, question number 14. So, using natural logarithm properties, so we have natural log x plus natural log 20. So we are using same properties of addition. So if we have multiplication, it will be converted into addition, which is going to be natural log 20 times x, which is going to be 20x. Okay? So from addition, we're coming backwards to multiplication. When base is the same, do we have the same base? Yes. Both of them are natural log. Question number 15. We have log 100 by base 3, 108, minus log 4 by base 3. Okay, this is going to be equal, since we have subtraction, it's going to come into division, right? So that is going to be equal logarithm (108) over 4. It's going to be equal logarithm 108 by 4. It's going to be 2 times 4 is 8. Remainder 28 divided by 4. It's going to be 7. So logarithm 27 by base 3. How much it's going to be? 3 we need to raise to power 3 to get 27. So the answer is going to be with its simplification, and we got result 3. Question number 16. Logarithm 2x plus 5 minus logarithm x. Okay, since it's subtraction, let me move this down. So we can use, since we have subtraction, we can convert into division, right? So this is going to be equal logarithm 2x plus 5 divided by x, right? Question number 17. What do we have here? 4 natural log x plus 3 natural log y minus 2 natural log 2. Okay. Well, let's say take z. Will be more fun. So let's do this first one, because it's addition here. We start with addition. So it's going to be, first we need to take care of this coefficient 4, which is going to come back here as an exponent, right? Look here. See, we have p, so I'm bringing back to here as a power right here. So this is going to be natural log x to power 4, and then plus natural log y to power 3, and minus natural log z to power 2. So what do we have? Addition and then subtraction. So addition we can convert into multiplication, right? Okay, x to 4 times y cubed. And subtraction we can convert into division, divided by z squared. Okay, so I'm going to solve another 8 problems, but I'm going to do this continuation in my other video. Therefore, it's going to be in 2 parts. This is part 1, and then I will publish the second video, part 2, because so it won't be too much in one video, okay? Well, that's all. Thank you for watching, and I'll see you in next video. Bye.